Welcome to another Numberful Wednesday. I am Teacher Julie and join me as we learn how to count, solve, and enjoy math. Imagine this. You are in a grocery store and you want to know how much 3 kilos of flour, 2 dozen of eggs, and 3 liters of milk cost all in all. Before you check the prices, you can construct a simple mathematical sentence letting F denote the price of the flour, E denotes the price of the dozen egg, and M the price of the milk. In your head, it would look like this. 3F plus 2E plus 3M. What do you call the mathematical expression used to find the total amount of flour, eggs, and milk in the grocery store? Very good! We call this polynomials. For today's session, we will talk about polynomials and the different techniques in solving problems in addition involving them. As we learn how to add polynomials, we will answer these 3 questions. First, what makes up a polynomial? Second, what do we need to remember when adding polynomials? And lastly, why do we need to learn about polynomials? Are you ready, students? Come on and join me in this numberful journey. Let's define a polynomial. A polynomial is a mathematical expression containing 2 or more algebraic expressions. They are often the sum of several terms containing different powers or exponents of variables. Polynomials are an important language in mathematics and algebra. It is nearly used in every field of mathematics to express numbers as a result of mathematical expressions. Polynomials are also building blocks in other mathematical expressions such as rational expressions. Many mathematical processes done in our everyday lives can be expressed as polynomials, such as summing the cost of all items on a grocery bill, calculating the distance traveled by a vehicle or object, and calculating the perimeter, area, or volume of geometric figures. Now let me ask you, what makes up a polynomial? Polynomials are composed of some or all of the following. First is the variables. These are letters like x, y, and b. Second is the coefficients. These are numbers attached to variables like 5 and 5x. Third is the constants. These are fixed values like 3, 5, and 11. Lastly are the exponents. These are usually attached to variables that can also be found in constants. Polynomials can have exponents, constants, and variables, but never division by a variable. And take note that they can have one or more terms but never an infinite number of terms. Let's take a look at these examples. Try to identify which are polynomials or not polynomials. Are you ready? Let's start. Is this a polynomial? Great! It is a polynomial. How about this? Awesome! This is not a polynomial because of the exponent -2. Exponents can only be 1, 2, and so on. What about this? That's right, it is a polynomial. Is this considered a polynomial? Correct! 5 is a polynomial. One term is allowed and it can just be a constant. Last one. Good job! This is not a polynomial because dividing by a variable is not allowed. You did great! Now that we know about polynomials, we can now try solving addition problems involving it. Come on, let's go! Take a look at how a polynomial looks like in this picture. To add polynomials, we simply add like terms together. But wait, what is a like term? Like terms are terms whose variable and their exponent, such as 2 and x squared, are the same. In other words, these are terms that are like each other. Note that the coefficient or the numbers that you multiply by, such as 5 and 5x, can be different. Adding polynomials is just a matter of combining like terms together with some considerations in the order of operations thrown in. As long as you're careful with the minus signs and you don't confuse addition and multiplication, you should do fine. To add polynomials, you may follow these two simple steps. Step 1. Remove the parentheses if there are any and place like terms together. Step 2. Add the like terms and simplify. Ready to try it? Let's start! To solve this problem, we can use two methods that you previously learned for addition of whole numbers back when you were in grade school. You can write this horizontally. Let's clear the parentheses first. This is easy to do when adding because there are no minus signs to take through any parentheticals. And step 2, let's group the like terms in accordance to their variables. Keeping them in order in alphabetical order. And finally, let's simplify our answer. These two terms are unlike because they have different variables, so we cannot combine them anymore. This means that 5x plus 3y is the final answer. Horizontal addition works fine for simple polynomials, but when adding plain old numbers, you don't generally apply the horizontal addition for numbers like 432 and 246. Instead, you would stack up the numbers vertically, one on top of the other, and then add down the columns. You can do the same thing for the polynomials. Here's how the previous example looks like when it's done vertically. Let's put each variable in its own column. In this case, the first column will be the x column. And the second column will be the y column. Notice how we got the same answer vertically as we solve it horizontally? The format you use, horizontal or vertical, is a matter of taste, unless the instructions explicitly tell you otherwise. Given the choice, you should use whichever format you're more comfortable and successful with. Note that in simple additions, horizontal addition is probably the simplest. But as polynomials get complicated, vertical addition is probably the safest bet. So you don't drop or lose terms and minus signs. Now, let's try this one. Try solving this problem horizontally or vertically. Let's solve this problem using a horizontal method first. For step 1, let's clear the parentheses first. Then, for step 2, let's group the like terms in accordance with their variables. Lastly, let's simplify our answer. This time, let's solve this problem using the vertical method. Put each variable in its own column. In this case, the first column will be the x cubed column. The second column will be the x squared column. The third column will be the x column. And the last column will be the constant column. Either way we solve it, we still get 4x cubed plus x squared minus 3x plus 1 as the final answer. Good job, students! Now, can you add 3 or more polynomials at once this time? I know you can, so let's do this! Try solving this problem horizontally or vertically. In solving this problem using the horizontal method, notice the ones in the third line. Anytime you have a variable without a coefficient, there is an understood one as a coefficient. If it's helpful for you to write that one in, then you can do so. This time, let's use the vertical method in solving this problem. For the final answer, we will not include the 0x term anymore. That's why 6x squared minus 2 is our final answer. That was fantastic, students! Now, let's go back to our 3 questions earlier. Polynomials are composed of some or all of the following. First is the variables. These are letters like x, y, and b. Second is the coefficients. These are numbers attached to variables like 5 and 5x. Third is the constants. These are fixed values like 3, 5, and 11. Lastly are the exponents. These are usually attached to variables that can also be found in constants. Adding polynomials is just a matter of combining like terms together. To add polynomials, you can follow these 2 simple steps. Step 1. Remove the parentheses if there are any and place like terms together. Step 2. Add the like terms and simplify. Polynomials are an important language of mathematics and algebra. It is used in nearly every field of mathematics to express numbers resulting in mathematical expressions. Polynomials also serve as building blocks for other mathematical expressions such as rational expressions. And And that's it for our lesson for today. I hope you learned a lot about adding polynomials. If you did, click thumbs up and share this video to other students like you to help them count, solve, and enjoy math. Don't forget to hit the subscribe button to hear from me and other Teacher Vibals. Again, this is Teacher Julie, and see you on our next Numberful Wednesday. Bye!